Greetings and salutations! Welcome to another Back to Basics type of video. This time around we're going to talk about Linux versus Windows. We're going to talk about some of the fundamental differences. I am very fond of saying that Linux is not Windows. I have said that in blog posts, forums, TV shows, videos, articles, whoever will listen. And what I mean by that is that if you are a Windows user and you sit down in front of a Linux system and you expect it to work, look, and operate like Windows, you are going to be very frustrated because Linux is a much different system based on a very different computing philosophy. In this video, I'm going to talk about 6 major differences between Windows and Linux. If we wanted to talk about all of the differences, we'd be here for several days, but we will confine ourselves to just 6. And these are the things that I find that people get tripped up on a lot when they're coming to Linux for the first time. So if you are new to Linux and you're just learning your way around, really glad you found this video. There won't be much to see on the screen because I'm just going to read from my notes and comment on them for this video. So if you would like to look away and look at something else, please be my guest. Now, there may be 1 or 2 spelling errors in here as well, gang. I don't need them pointed out because it doesn't matter. It's just my notes. That's all it is. So the first thing that you need to understand when you're comparing Linux to Windows is that Linux is yours and Windows is still theirs. And that is the simplest way that I can express the differences in how software is licensed in Windows versus Linux and the difference between proprietary software and free and open source software. So let's get into that a little bit. The EULA for Windows clearly states that Microsoft maintains full access to your Windows system and any personal data stored with it. They reserve the right to change any software or settings at any time. The user is leasing the software. They do not own it. Attempting to change or redistribute Windows in any way is a violation of copyright law, and you can be put in jail for it. Much of the system is off limits to users, although Windows does employ the use of administrative access levels. MS is in essence a hyper-user because code can be executed by them remotely without local approval. This leaves doors open to nefarious third parties who want to add malicious software to Windows systems. So what does all that mean? Well, first of all, you're leasing the software. That's an important point. When you agree to the EULA, they state that they still own the software and they do maintain access to your system, which means they can change anything they want to and you have no legal recourse. So if you are working on a project that you have been working on for 4 days that's going to make or break you, we're talking $1 million type of thing, and Microsoft decides that they want to install updates and restart your computer in the middle of that, and you lose work that sets you back and you lose that $1 million, you can't sue them. That's what that basically means. And of course, having access to all of the data on the computer means exactly what you think it does. They can look at your stuff and see what you're doing and funnel it back to them if they want to and do whatever, sell it, do whatever they want to it. Talking about redistributing software. So there was a fella not too long ago who had this idea that he was going to have a bunch of CDs pressed that would allow people to recycle computers. These were like the CDs that Dell put out with Windows on them that you would use to reload a computer. Of course, they're not available anymore widely. And he had some of those pressed and he was distributing them to recycle old computers. Well, he got busted for it because he was technically redistributing Windows and he ended up in jail. In Linux, we have this concept of the root user or the super user. This is a person who has absolute control over the system. If you install Linux on your system, you're going to be that user or you're going to have those privileges. In Windows, even though you have administrators, you still have this back door open where it's like Microsoft is a hyper user, which means they're above everything else on the system and they have access to everything. On a Windows system, you don't have direct access to everything like that. And what can happen is that somebody can put a virus on your computer and they can create directories and files in your file system that you can't delete, even if you have administrator access, because of this hyper user type environment that Windows runs in. And when I used to, years ago, I used to do IT, freelance IT. I used to work on Windows systems. I found that many, many times that people would get viruses and that would happen, and you would have what they call rootkits and things like that. And the only way to get rid of it was to completely reformat the machine. In contrast, Linux users with administrator privileges must approve the installation of all software. It doesn't matter what it is, where it comes from. You're not going to install any software on your Linux system unless you put your password in and make it happen. So if you have a Linux system and you are the root user and you have 4 or 5 other people with accounts on that system and they are basic users, they cannot install software. So that makes things a lot easier. They cannot click on a web page and install anything within the Linux system itself. They could install something within their browser, but that's as far as it goes. You have to authorize any changes to the system that affect other users. So what that means is that anytime that you do anything to a Linux system that might change somebody else's work environment that has access to that system, you have to have root user privileges. And a lot of Windows systems get messed up because what happens is that you have 2 or 3 accounts on it and somebody logs in, screws up the system for everybody else. It happens again and again and again. And we'll talk more about that as we roll along. You are encouraged to customize your Linux distribution in any way, shape, or form that you want to. Whereas, as we mentioned earlier, in Windows you don't have direct access to a lot of stuff in the system. Redistribution of free and open source software is encouraged. Please give it to your friends. If you download and install Linux and you like it, take the disk over and load it on somebody else's machine. Let them play with it too. No problem whatsoever redistributing it. None at all. Linux users have full access to every part of the system. That means that if you have the knowledge and you want to take the time to learn how to do it, you can change everything about your Linux system to suit your needs. Whereas in Windows, I have in the past, when I was working with web servers, I would have consultants there and people that were coming from large corporations, systems that I was working with, and we would be standing there and I'd go, "What's it doing?" And they'd say, "I don't know." And that's how I'll remember Windows, is staring at a machine going, "What's it doing?" And somebody saying, "I don't know." Because you really honestly don't know what the machine is doing. And of course, no code can be executed or access granted. I have grated there. I told you there'd be a misspelling somewhere. To a Linux system without the express permission of the root user. We've already talked about what root is. So once you get that idea in your head that you have total access to that system, then it makes using Linux a lot more fun, and it makes it a more secure experience. And for a lot of people, it's very liberating, because then they start to do things with their computer that they haven't done before. I've helped a lot of users through the years, and people who are running Windows, they would be afraid of the system because they were afraid they might break it, and then they'd have to have it reinstalled or pay a lot of money to get it fixed or whatever. In Linux, hey, it's free. You can reinstall. Do whatever you want with it. So that kind of leads into the next thing, which is that Linux desktops do not need any antivirus software. Let me repeat that. Windows desktops do not need any antivirus software. Windows is still vulnerable even with antivirus installed. And it is not simply a matter of Linux having less users that makes it more secure. I've heard that said over and over again. That's simply not true. 3/4 of the internet runs on Linux. The system is inherently secure. A case in point would be Linux web servers that are constantly banged on by would-be hackers. And I can attest to that personally, because the Easy Linux webpage and the Easy Talk forum, they run on their own server, which I have access to. And every time that I go to log into that server through the secure shell, SSH, it tells me how many failed attempts to log in and gain access to that machine happened. And every day that I log in, I see it. So those systems are very secure. Now, we will hear in a great while about some giant breach that some website was hacked into, and a bunch of users' data was leaked out or whatever. Usually that goes back to the administrators doing something stupid, like running software that has known security vulnerabilities in it that should have been updated, which wasn't, bad practices, whatever. But it very rarely comes down to somebody actually getting through the basics of Linux security. Linux is definitely the safest choice for desktop computer users. No OS is totally secure, that's absolutely true, but the chances of Linux users getting a virus are very, very small. I liken it to the chances of you walking outside and getting hit in the head by a meteorite. It is possible that that could happen, but it is very improbable that that might happen. Now, I constantly hear from people who are just stunned by that you don't need to have antivirus. And they go, well, yes, there's antivirus available for Linux. Yes, it is. There are many antivirus solutions for Linux. However, most of those solutions do not scan for viruses the way you think they would. They're not looking for somebody to hack the system. What they do is they scan data on the system looking for Windows-based viruses, so you don't redistribute them. A virus written for Windows is not going to hurt you. It can't. So even if you see an exe file on your computer, which is a known virus, and it pops up, it won't hurt you. You're on Linux. It doesn't run. Now, a caveat to this before we move on is that people want to run things like Crossover and Wine and Play on Linux. And if you do have those installed, guess what, ladies and gentlemen? You are now vulnerable to viruses, because the Wine system actually creates a bridge between the personal data that you have stored in Linux and what the Windows programs can see. So if those programs are somehow feeding information back home, or if they are vulnerable, then guess what? Your whole system is vulnerable if you run Wine. Something to keep in mind. Windows users are encouraged to install and pay for antivirus software that is only about 20% effective. That's what the experts say. And even though it sucks to have this software on the machine, because antivirus software severely limits system performance most of the time, it's cruddy software to begin with. Don't even get me started, because this is a pet peeve of mine. The entire antivirus industry for Windows is a hack, and it's a racket, because they employ a lot of what I call security theater, which means that you'll have these little widgets on the screen, and you'll have little things that tell you it's doing this, and it'll nag you to install the latest definitions and all that stuff. They are doing that because it makes it looks like that your money is going for a good cause, that it's actually protecting your system. It's all smoke and mirrors, it's all theater, because with Microsoft's backdoor, it makes no difference. The system can still be changed, antivirus or no antivirus. And I can tell you that when I was doing a lot of IT work, and I was doing a lot of system reloads for people who had viruses on their system, I used to do that to make money when I was working on Windows freelance. Most of the time, they had fully functional, updated antivirus software running. Didn't matter, the machine still got messed up. Somebody clicked on something they shouldn't have. Somebody was fooled into giving permission. Somebody installed software that had something in it that they shouldn't have. That's usually what happened. And those systems were completely messed up, even though they had antivirus running. So like I said, you don't need it on, really, I'm serious, I mean it, you don't need it on Linux. You just don't. Don't even get in the comments and try and say it, because it ain't true. I'm just letting you know. Linux security depends on stringent observance of user privileges, we've discussed that, and file permissions, along with keeping the system up to date with the latest security patches. So if you want to be immune from vulnerabilities, or at least immune is probably too strong a word, if you want to be protected against, then what you need to do with your Linux system is make sure that you have all of the updates installed. Do not hold back any updates. Just don't do it, because once the vulnerability is discovered, a patch is usually issued before anybody gets a chance to even take advantage of that vulnerability. But once that's done, it's a known vulnerability, and then people out there look for it. Now, even with that said, it's still going to be difficult to get into your system because of the way the file permissions work and the way the user privileges work in Linux. So, but if you want to be super, super, super safe, make sure you install all your updates. So let's talk about software in Linux, because this is hugely different from what people look for in Windows. Linux uses a centralized software approach. My mouth doesn't want to work. Windows does not. And what that means is that in Linux, when you install a Linux distribution like Ubuntu or OpenSUSE or Arch, you have access to maintained, curated repositories. These are online websites where software that is packaged and tested with that distribution is available to users. It's free, and you can do it by opening up a graphic software manager, or you can just put a few simple commands in a terminal. So let's take a look at that right now. I mean, this is worth looking at because this is a big deal in Linux, and it's something that's changed. So if we look at the software application called Ubuntu software, we get a lovely thing here where we can search for software, we can look through categories, and all we have to do is click on things to install it. And every major graphic-based Linux distribution has some piece of software which does that. I mean, I don't know of any that don't at this point. And they have a lot of very useful software that's available for download, and it's just downloaded to your system, and it comes directly from the repositories. So that is the first place to look for software in Linux. It's the safest place to look. A lot of people who come to Linux from Windows get themselves in trouble because in Windows, the mindset is I have to go look for my software and I have to download it from other websites. We don't do that in Linux very much. And we'll talk more about that as we roll through the notes here. So most Linux software is available from distribution-specific online repositories. Linux users have access to thousands of free programs. Don't even have to pay for it. Just install it. Windows also has a store, but most Windows users still think in terms of downloading software from independent websites, most of the time to get around the money, the price. Because pretty much everything that is in the Windows Store, you have to pay something for. Even if it's $1 or $2, it's a paid type system. Not everything in there, but a lot of it is. And people think in terms of, well, if I go grab this other piece of software, which is quote-unquote free, then I can get around that. The problem with doing that is that most free software offered for Windows has malicious software built into it. And that's why it's free. I mean, if you're downloading it, there's got to be a reason, right? For Windows, a lot of the times you need to be very suspicious. And people do this with Linux. They install Linux and then they go off and go, well, I need this. And then they go, and just like any other ecosystem around any other operating system, there are people out there who are offering crappy software for Linux that is not well vetted, it's not packaged properly, and you can get yourself in big trouble because not everybody does a great job of it. That's why the novice Linux user should never have to build software from source code. Don't do that. Don't do that until you get to a point where you understand how that works. And not many people who are using Linux on a casual basis at home are actually need to build software. You just don't need to do it. You don't. Now, if you want to be a programmer and you want to learn about building software from source code, great. You go right ahead. But if you think that you need to do that to get a hold of a piece of software, back off, rethink it, and go look for an alternative. Do some more research. You shouldn't have to do that. Reputable software vendors will provide proper packaging for Linux. Avoid those who do not. That's a very important point, because what you'll hear about, somebody will say, well, there's this great program and you can run it on Linux. And then you go and look, and what you actually get is that they will download what's called a tar file. And then you're supposed to follow these directions to build this piece of software and install it on your local system. First of all, you're not going to get any updates for that. Second of all, the differences between Ubuntu systems, Debian systems, Arch systems, Fedora, Red Hat systems, all of that entire thing, you can't guarantee that it's going to work on each system. 9 times out of 10, those directions don't work. You're barking up the wrong tree. You really and truthfully do not have to do that. Barking up the wrong tree. Did I say that right? Yeah, I did. So that's a very important point to put out there. In addition to distributed repositories, repositories, big words, Linux users can download software from third-party package management systems like Snappy and Flatpak. This is new. We have the Snap Store, which is something that's run by Canonical, which is the company that distributes Ubuntu, and software that is put in Snap packages can run on any Linux system, and it doesn't matter what distribution you are. And then there's another one called Flatpak, and Flatpak does pretty much the same thing. For instance, Linux Mint now offers Flatpaks in their software manager program, and you can choose from software that's been packaged in Flatpak. Now, this is just another third-party way of distributing software. Ubuntu offers private package archives, which are known as PPAs. These are a special kind of repository that can be run by developers who are putting out software for Ubuntu. Maybe their software hasn't made it into the Ubuntu repositories. Maybe they want to make newer versions than what is in the repositories available. You do that through PPAs. And also, some software in Linux is available for, by direct download. So for Ubuntu and Debian systems, you can download a deb package to install Google Chrome, for instance. Or you can install an RPM package in a Red Hat, Fedora, or CentOS, or OpenSUSE system. That's called RPM Linux, and there's Debian-based Linux. And it's those... You'll run into those mainly from people who are distributing proprietary software. Like, for instance, if you install Chrome, TeamViewer, you're going to see those. They're okay as long as they come from a reputable source. PPAs are okay as long as they come from a reputable source. You're totally, completely safe, at least from getting some sort of virus or installing unwanted software, if you do it from the repositories, which is where you should start. And if you're starting out, I would really suggest that you install something like Linux Mint, because they have pretty much all the software you need to get going. You got Firefox web browser. You're going to have an entire Office suite in there. You're going to have all of the little bits and pieces that you need to get started and do something with Linux and get things accomplished. So take it slow. The first thing that you do with Linux software is not to go out and try and replace it. Learn it, get to use it a little bit, give yourself some time. Now, this is an important point about Linux software because I get this all the time. Linux software is installed in predetermined directories. It cannot be moved or installed elsewhere. We hear this all the time because in Windows you have this concept of being able to tell the system, I don't want to install the software in under the programs directory. I want to put it over on drive G that I've got plugged in because I don't have enough room on the system. No. Linux software does not work that way at all. It installs in predetermined different directories. It's not one executable file. It's a bunch of files. So some of them go into, for instance, like /user/bin, and then some of it would go into /user share /applications. That would be like your desktop menu entries, icons. There's all different places for that. So once you install a piece of software, it's put where it needs to go and runs in the system. So that's an important thing to keep in mind. Next thing to talk about, major subject here, is Linux has built-in hardware support. Windows requires users to find and install drivers. Now, there's a lot of gray area in here, so before you jump up and start putting in the comments, well, Windows will help you find a driver. Yes, it will. It will do it with a lot of basic stuff, and but a lot of the times it will find an old driver or an incompatible driver, And that leaves the user out there trying to figure out to get drivers for things like their Ethernet card, to get drivers for things like their motherboard, the chipset. It's crazy. Some Windows systems are easier to set up than others, but a big chunk of setting up a Windows system is going out there and trying to find drivers that are not full of malware. It's just driver hell. You go and look for a driver for something, and all of these BS sites pop up where it's like sitting there saying you've got your drivers there, and you go and look, and it's a bunch of it's not even drivers. It's a bunch of crappy stuff. It's horrible. It's a horrible situation. Linux has that built-in hardware support. So that means that usually when you install Linux on a system, it either works or it doesn't. That's all there is to it. Those drivers are modules in the kernel. So hardware with Linux support usually just works without the need for users to do anything. If it's supported, it's going to work, and you don't need to bother with it. Some things have proprietary drivers associated with them, like video cards. Certain Wi-Fi cards need to have proprietary drivers. A lot of the times, your distribution will automatically install those sorts of things if you tell it when you're installing it that you want that done. Or once you get it booted up, you're going to find that there's a graphic tool in there that will tell you what drivers are available, and you just click on it to install. It's really that simple. And if you have an HP printer, for instance, usually just plugging it in to the system is all it takes to get the drivers installed. If you're running like Linux Mint or Ubuntu, just plug it in and it'll just automatically start working. And I know that a lot of people go through this thing where they have, they'll have a printer that's marginally supported, and there'll be some drivers somewhere that they have to build from source code to get it to work. Sometimes it works, sometimes it doesn't. My advice to people who run into those situations is buy another printer. If you're going to be running Linux, get one that's going to be well supported, and get one like, HP is a really good brand, because HP, they're just supported out of the box. And if you have an older printer, before you jump over to Linux, see what the support is like before you do that. It's getting better and better all the time, though. It's really less of an issue than it used to be 5-10 years ago, but we still hear things about that. And what's really wild is that when I was doing one-on-one installs with people, I don't do that much anymore. There were people who had brand new machines that I thought, okay, we're going to have driver problems. We're not going to be able to get this thing running. And then they install something like Linux Mint, and it would be the latest version, and everything would just work. There would be no proprietary drivers, no need to change anything. The whole system. Touchscreen, touchpad, everything. So that's kind of the way drivers work in Linux. It's a very different type situation. Now, this is a really important point. Linux updates everything at once, and Windows does not. So this could be like Windows updates versus Linux updates, and what makes them different. Most Linux systems look for updates automatically and alert users when they are available, which means that once every 4 to 6 hours, usually, that part of the system, it goes out and it just checks the repositories that you have hooked up to the system where you're getting your software from to see if there are new versions of all of the software that's installed. And if it gets it, it says, hey, in some way it will alert you, or you can check in on it to see what the deal is. That does not run all the time in the background, and that's an important point. We'll talk about that more in just a bit. Windows only updates Windows and some select MS software. So all the hoopla over Windows Update and keeping your system up to date, that's all it does. So that is why a lot of Windows software ships with little garbage stuff running in the background that's looking for updates all the time, which bogs down the system resources. That becomes a nightmare after a while. Even with that said, Windows updates can be very problematic. Windows is notorious for downloading and installing, I just put install updates, and then restarting the machine without users' consent. That horror story has been repeated over and over and over and over and over again about Windows, is that I was doing something, it was important, and the machine just decided to reboot. Linux will never do that. It will never happen. It will tell you there's updates available, but you yourself are going to have to install them. And even while they're installing, after they're installed, it's not going to automatically restart the system. It may nag you to restart because it's a good idea to restart after you do kernel updates, for instance, and things like that. But Ubuntu has a great way of telling you whether you need to do that. In Ubuntu, you'll get a sign that says software is up to date, and you just click OK. That means that you don't have to do anything. No restarting necessary. If you do have to restart in Ubuntu, you've installed something that's system level that needs, that kind of thing to happen, then it will tell you you need to restart your system. It's awesome that way. And of course, we talked about Linux does not require programs to run in the background to listen for updates, which a lot of Windows programs do. And that really bogs down and slows down a system. You have crap running in the systems tray, crap running in the background, and keeping up with that used to be a big pain in the butt. That may have changed a little bit. You got to remember, I haven't run Windows full-time in a long time, but from what I'm hearing, that hasn't changed much. And Linux will never restart the computer without your permission. Okay, and the last thing we're going to talk about is a technical system thing, because this is a major stumbling block, and then we're going to end with this for new people that come along, and that is Linux uses /dev for drives, whereas Windows uses its ABCs. So what does that mean? On a Windows system, you are used to this concept, which dates all the way back to DOS, where you have an A drive, which would be a floppy drive if you had one. So A and B are for floppies. Your C drive is usually your first hard drive. Your D drive would be your first CD-ROM drive. That came along later. And then anything after that, E, F, G, H, whatever, going on ad infinitum, or whatever other drives that you have hooked up to the system. You can also have network storage hooked up to the system that appears like a drive, and it will be issued a drive letter as well. In Linux, the way it works is that drives are represented in the dev directory. We'll take a look at that. So let's read through here. Linux treats all storage devices and network storage as a directory. So any hard drive or network storage can be mounted somewhere within the file system. Windows assigns these arbitrary letters to identify storage devices and network connections. And so basically what you're having happen here is that if you hook something up, it just becomes a letter, and then you can point to it by going to like My Computer or in your file manager, which works for a small system, but it doesn't work on a scalable system. It doesn't work on a large system. And you must remember that Linux comes from the days when computers filled up whole rooms, and there may be many, many different network connections, many different drives, tape drives, hard drives, floppy drives hooked up to this system. And that is why it does that the way it does. Available devices can be found in the dev directory along with other, I should have put a with there, input-out devices and virtual devices. That kind of fell apart. Storage devices can be mounted anywhere within the file structure. So let's open up a terminal here on our Linux system. Let's take a look in that dev directory. So we're going to actually jump to it. I'm going to cd to dev, right? And then we're going to list the storage in dev. Look at all this stuff. What is it? What is all this stuff? Well, this is your devices on your system. These are output devices that are available on your Linux system. Make this a little bigger so it's easier for everybody to see, including me. So let's just kind of look here at some of the different things that we have listed in this Linux system right here. So what have we got? Let's go over here to TTY. These are terminals that are open on your system. That's what TTY stands for, short for teletype. So a terminal is considered to be an input-output device. And then you have keyboards that are hooked to terminals and things like that. So let's look, where else can we look here? Let's look under S. Let me see here. That's looking for the S's, folks. There we go. So you'll see that we have SRO here, which is short for your DVD drive. That's what that stands for. So I'm looking for the SD devices here. So that would be way up here. Okay, so here we've got SDA and SDA1 and SDB right here. Right there. those right there. And what that represents are your hard drives and any drive connected to the system. So let's open up another terminal, and let's run this command lsblock, which shows everything that's hooked up to the system. So here we have SDA, which is the first hard drive in the system, or SATA drive 0. And that is SD, which is short for SCSI device. Okay. And then we have SDA1, and that 1 represents the first partition on that disk. If there were more partitions, we'd have SDA2, SDA3, SDA4, and so on. So we have 2 hard drives hooked up to this system. One of them is mounted in the home directory, which is right there, and the other one is mounted in the root directory. So in Linux, if you plug in a drive, and I'm reaching over here and getting a blank drive that is one of those little USB stick drives. We're going to plug that in. I'm going to show you where that shows up. So I'm plugging it in the system now, and it will recognize this, and it'll automatically mount it in a predetermined location. And so let's run this command again. Now you see that we have the new drive showing up as SDC. That would be right here. And then we have SDC1. Make that a little bigger as well for people looking on low resolution devices. I know you're out there. So now you can see all of the drives that are hooked up to this system. And that is when I plugged in that drive. And I can have a drive in the system that's not automatically mounted anywhere, and then I can mount it manually. So for instance, let's try a little experiment here as we end up our video, just to show you guys a little bit about how this works. So if I want to move this somewhere else, let's say that I have this drive mounted up. So the command that I'm going to use is sudo, which gives me root privileges, unumount. Don't put the N in there. And we're going to SDC1, get it right, dummy, dev SDC1. Okay, we're going to unmount that. I'm going to ask for my password. Got no output, so it did it, said it did it. Let's run lsblock again. You'll notice now that SDC is hooked to the system, but it is not mounted anywhere. So let's actually mount that somewhere. We can put it anywhere we like, any empty directory. Now, in Linux, there is a directory that is provided for that, which is called MNT, if you want to temporarily mount a device. So we'll use that one. You can also mount it in your own home directory anywhere you like. You can create an empty directory. I'm just using this as an example. So now we're going to do sudo mount, and we're going to choose dev SDC1, and finally we're going to put this in MNT. So that's the command to do that. Done. So now if I cd to, well, let's see, how about we just, it's a blank drive, you're not going to know it's there, right? Don't cd, just run lsblock again and it'll tell us. So now you see that that drive, SDC, is now mounted at this special directory called MNT. It's that simple. Now, that might seem a little bit more complicated when you think about using your ABCs, but when you stop and think about how flexible this is and how you can make any storage device or even network storage appear anywhere you want in the file system, that means you could have a completely separate hard drive that you could use to store your music on. You could have your music on a network server, and each one of your systems, you sit down and you have exactly the same thing show up. You get all of these different ways of doing things. So that is something to keep in mind. Go ahead and clear that. We don't need that, and we're done there too. So there you go, gang. That's my video. That's what I've got to talk about, the major differences between Linux and Windows, and that's just an introduction. Mouth don't work today. And there's a whole lot more to talk to about and to, of course. I'm okay, I swear. Your feedback is always welcome, as usual. Please be sure to give Easy Linux a like on Facebook. Thanks. And check out Easy Linux on the web. That's how you can get to Easy Talk. You can check out what's going on there in our new forum that we've had up for just a little while. Got quite a few members, people talking there. Also check out freedompenguin.com for lots of great stories about Linux from contributors such as myself. And we will do this again soon. Thank you so much for your time. Thank you for watching.